Hi everyone. In this video I'm going to be introducing you to my new frame design, the AOS 5.5. I'm going to explain why I chose to design a frame for 5.5-inch props when it's a slightly non-standard size. I'm also going to be taking you through the design of the frame step by step so that you can see how all the different features of the frame work together to give it the performance that it has. And then, if you want to learn more, I'm going to be showing you where you can find out more about the frame design and where, if you would like to try out the frame, you can go and buy it. So let's get into it. So before we can answer the question of why I've decided to design a 5.5-inch frame, I think we first need to ask, why are 5-inch props so popular? And I think based on my analysis of disc loading, propeller tip speed, and the various scaling laws that govern the weight of the different components in a quad, I think I understand the reason why. 5-inch quads, in my opinion, provide the best compromise between lift capacity and responsiveness for an action camera payload of up to around 100 grams. This allows 5-inch quads to be fast, to be durable, and to be powerful enough to capture incredible FPV footage with cameras like the Hero Session and the Hero 5 Session. It's really no surprise that this combination of factors and the availability of these fantastic cameras at around the 75 gram mark led us to all fall in love with the 5-inch class. But in recent years, things have changed somewhat. GoPros are getting better, but they're also getting heavier. And if we want to continue to use these larger, heavier action cameras, our thoughts and our feelings about frame design also need to evolve. I've made a graph here of the action camera weights of some different cameras, and you can see that the Hero 5 Session and the Runcam 5 come in at just about the 75 grams for a Hero 5 Session and a little bit less. I think it's 56 grams for a Runcam 5. But if we look at some of the more recent cameras like the Hero 8 and the Hero 9, you can see that they are twice the weight nearly of a Hero 5 Session. Now, in one of my previous videos, I covered the effect of prop diameter and quadcopter weight on the responsiveness and the speed of a quad based on an analysis of propeller tip speed. I'll put a link in the video description to that analysis so you can watch the whole video and understand the topic more fully. And what I found was that there are these lines of constant disc loading. And these lines allow you to compare the performance of quads even as their weight and their prop diameter change. And I also found that depending on the application, there is an ideal disc loading. And that ideal disc loading depends on things like how fast you want the quad to go, how responsive you want the quad to be, how durable you need the frame to be in crashes, and how long you want to be able to fly on a single battery. And taking all of these things into account, I found that for freestyle drones, this blue line of about 8 grams per square inch was really ideal for that application. It gives you enough lift capacity to carry a good action camera, enough durability to survive crashes, and enough speed, power, and responsiveness to get really dynamic, exciting footage. And so when I designed the AOS 5, I put that frame right on that blue line. So a typical build of the AOS 5 with something like a Runcam 5 or maybe a Hero Session 5 comes in right around 650 grams. And it runs 5.1-inch props. So you can see that that sits bang on that blue line. But what if we wanted to run a heavier camera like a Hero 8 or a Hero 9? Well, we're going to need to move up this line a bit. And when you include the extra weight of slightly bigger motors and perhaps also a slightly bigger battery to handle the larger props, you find that the all-up weight of that design comes in at right around 750 grams. And for that weight, the ideal prop diameter is 5.5 inches. So the AOS 5.5 again sits slap bang on this blue line, because it is designed to carry these larger, heavier action cameras with absolutely no compromises. So now you understand why the AOS 5.5 exists, I'd like to take you through all the features of the design. Now the AOS 5.5, similar to the AOS 5 before it, has been designed using finite element methods and harmonic analysis simulation in order to try and give it the absolute best possible vibration and resonance performance. Now, the reason why this is important is that if you can reduce the amount of vibration and the amount of resonance in your frame, you can run less filtering, you can run higher PID gains, and both of those things together will give you a much better, more responsive flight feel. So that's the goal, and I'd like to show you how I tried to achieve it in this design. I'm really excited to take you through all of the design features of the AOS 5.5. And we're going to start by looking at the arm. Now the arm on the AOS 5.5 has a really similar overall intention to the arm on the AOS 5. So we have this very characteristic truss structure that I used on the AOS 5. Now, the reason for sticking with this truss structure is exactly the same as before. It provides really excellent control of a critical resonant mode, which is a resonant mode where the motor wants to twist around the end of the arm. And it's very, very hard to manage this with a traditional single arm design. But the moment you go to a truss, because you've got this much, much wider base here for the arm, you can have really incredible torsional stiffness in the arm with this shape. And so that motor just can't twist on the end of the arm anywhere near as easily. And so that really helps with that particular resonant mode. The arms are still 6mm thick, and that's really quite thick for a 5-inch quad. But you need that thickness and that material to provide stiffness against the motor wanting to bounce up and down on the end of the arm, which is another resonant mode that is really problematic for these types of 5-inch freestyle quads. Because we've made the arm quite thick and I wanted to save as much weight as possible, the arms are very, very slender. The individual struts are really slender. You will notice, however, if you've got your calipers out, that the arms are very slightly wider at the base than on the AOS 5. And they need to be very slightly wider for two reasons. The first is that the length of the arm is ever so slightly longer, because now we're working with a 5.5-inch prop rather than a 5-inch prop, so the arms are just about 10% longer. And also, I'm anticipating that because you're going to be running a larger motor, you also are probably going to have a slightly heavier motor for managing a 5.5-inch prop versus a 5-inch prop. And so I wanted to add a little bit of material to better handle that little bit of extra weight that you might have on the end of the arm because of that larger motor. Another really big advantage of the truss structure is to do with its strength. Now, when you experience a frontal impact in a traditional frame where you just have this strut here, the impact here creates an incredible torsional load around the root of the arm, and it creates an enormous bending moment in this strut of a traditional arm. And that bending moment can often overwhelm the arm and cause it to snap. And that's because carbon fiber isn't as strong in bending as it is in tension or compression. And that's where the truss structure comes in. With a truss structure, that same loading coming from the front, rather than just putting bending load on this strut, it actually puts tension in this strut and compression on this strut. And because we now don't really have as much bending moment, the carbon fiber is much, much stronger in tension and compression than it is in bending. So the truss structure provides a real durability benefit in those types of loading scenarios, particularly that kind of head-on impact. And obviously, should you impact on the back arm, now it's this strut that is in tension and this one that's in compression. But the carbon fiber is much happier in that sort of loading situation than in a bending loading situation. And so, that can give a benefit. You'll see that we have these devil horn or bunny ear motor protection features on the arm. Now, a lot of pilots are really demanding this nowadays because they've found that these types of devil horn or bunny ear motor protectors, they take the hit in a crash. And that protects the motor and particularly the bearings of the motor from taking damage. And what that helps to do is to keep your bearings in your motor running smoother for longer. And obviously in a frame that is designed for the best possible vibration and resonance performance, I had to make sure that I put these motor protectors in, because it's no point having a frame that has fantastic vibration performance if you're just going to let the motor take hits in crashes, and that's going to make the bearings sound rough and run rougher and create more vibration. So we want to protect those motors, keep them running really smooth so that we can have a really low vibration, really low gyro noise situation on the frame. If we come over to the body of the frame now, you can see that the center section of the body is much wider than what I had on the AOS 5. And the reason that I've done this is for two reasons, really. The first is that with the longer arms, because of these 5.5-inch props, it actually really helps with the vibration and resonance to try and minimize this length as much as possible. And so I've brought the middle section out a little bit to try and just keep that length under control. And that really, really helps with the stiffness for several vibrational modes that are quite critical for the performance of the frame. Also, by making this center section wider, I've actually been able to move the flight control stack from either the front or back position, which is where it was in the AOS 5, into a central position. And you can have a 20 by 20 or 30 by 30 stack in the center here. And the reason for this is quite subtle. There's a particular resonant mode where the two sides of the frame, the front and the back, rock this way. Sort of, the frame is twisting. And in the AOS 5, I was able to manage that by doing very careful cutouts of the bottom plate and the top plate to provide enough torsional stiffness to resist that mode. With the AOS 5.5, when I tried to take exactly the same approach, I really found that I was adding a little bit too much weight for my liking, and so I was searching for a better solution. And the solution that I found was, if you place the flight controller dead center in the frame, this mode where the motors are twisting kind of opposite to each other like that, it doesn't actually affect the flight controller at all. So although this vibration is happening, you don't see it in the gyro trace. And that is a real benefit to putting the flight controller centrally mounted on a slightly larger frame like this. And that's why I've moved in this direction for the AOS 5.5. And that has allowed me to make the frame a little bit bigger without having to add a lot of extra weight to provide extra torsional stiffness. So I hope that you feel that that trade-off has been worth it. There's also a 20 by 20 stack mounted in the front and in the rear. So you actually have 3 mounting positions in this frame rather than the 2 in the AOS 5. And that's just because the frame is slightly bigger and the body is slightly longer, so it's easier to manage that. And you could put, for example, a Caddx Vista or any other 20 by 20 mounted hardware on either the rear or the front stack. There's plenty of room in the back of the frame or a full-size DJI Air Unit, if that's what you want to run. And I have a build actually, which I'll show you in a second, which has the DJI Air Unit along with a 30 by 30 stack in the center to show you that there is space to fit all that in. If we come now to the front of the frame, the camera plates, there are going to be two options for these camera plates. First off, there's going to be a 20mm option, which fits the old style DJI camera. So that's the camera that was supplied with the original DJI Air Unit and with the original Caddx Vista. And a lot of pilots still agree that that DJI camera does have the best image quality. So if you have it, or you're still able to get hold of it because it's not manufactured anymore, then you might want to go for the 20mm wide camera plates. However, for those of you who are running maybe an analog setup, or maybe you're running the Caddx Nebula Pro camera, or any other micro-sized camera, you probably want the 19mm camera plates, because that will mean that you don't need to mess around with washers. And that was a request that I got with the AOS 5, was to provide two options, 19 and 20mm. And so I've provided the same two options on this frame. The camera plates are made of carbon, 2.5mm. And the reason that I've chosen carbon fiber is that it is stiffer, it is stronger, and it is lighter than aluminium or titanium. Its specific stiffness, specific strength are higher than aluminium or titanium. It's also much cheaper than machined aluminium or titanium. And so these are going to be inexpensive to replace if they're damaged, and are going to actually provide more protection to your camera than an aluminium or titanium camera cage. If we come back here, you can see these two cutouts in the top of the frame. If I turn to the side, you can see that these are actually tongue and groove in from the camera plate. So the camera plate locks into the top plate. Now I did this on the AOS 5 to provide additional stiffness to the front side of the top plate to handle the weight of a GoPro. And I've taken this one step further with the AOS 5.5. Obviously, this frame is designed to handle even heavier cameras than the AOS 5. So we're talking your GoPro Hero 8s and 9s. And having these two cutouts and having the camera plate extend even further back, combined with the extra material around this area here, really provides a lot of additional stiffness in that front section of the top plate. And that's going to be better able to manage the weight of the heavier cameras, the GoPro Hero 8s and 9s, and that's going to minimize the risk of you getting any jello in your HD camera footage. If we come back from the front now and we look at the center of the top plate, you can see that because we've got this wider center section, I've actually included two battery strap slots here. And this is so that your battery strap can easily fit around a sort of typical size battery that you'd want to run on this quad, either something like an 1100 or maybe a 1250 milliamp hour 6S, or a 1500 or 1800 milliamp hour 4S. The cutouts in the top plate, and actually all over the frame, are really aggressive. I've tried to remove as much weight as I can without sacrificing any of the strength or the stiffness in the design. And I've used a lot of finite element simulation to try and optimize these cutouts. And I hope that what it's going to enable is for the frame to remain really, really strong, really, really durable, but be much lighter weight than other similarly strong and durable frames, because that simulation has guided exactly where to remove material and critically where to leave material in. That also extends out to the arm, where I've actually extended this motor mount slot here out into the camera protection. Again, that is just to save weight. I'm removing material from an area where it's not doing very much work. And because that is so thick, it's 6mm thick, this arm, that that actually removes a fair bit of weight by extending those slots, particularly because we have 4 arms. If we come to the back of the frame, we can see that similar to other frames, we have an AOS logo. You can see that this is a prototype because the AOS logo is actually reversed in this case. Yours won't be, yours will be correct. And I hope that you think that gives a sort of visual appeal to the frame. Now, finally, I want to talk about the assembly of the frame because I've really tried to make this frame as easy as possible to assemble. You've got 8 screws on the top plate. You've got 8 screws on the bottom plate. And you've got 8 standoffs. And that is it. This frame is very, very, very simple to put together. If you need to swap an arm, for example, it's just 2 screws, well, 2 of the bottom screws there. You remove those 2 screws and then you can swap the arm should you happen to damage one. And none of the screw mounts for the arms are shared with any of the electronics. So you're never going to have that issue where you need to remove a screw from the flight controller stack in order to change an arm. That's just not an issue. The GoPro mounting on the top plate is the same as the AOS 5. It's a 32 by 32 millimeter GoPro mounting. And it's designed such that any camera mount that fits the AOS 5 will also fit this frame. And similarly, any camera mount that fits this frame will also fit the AOS 5. So you don't need to worry about that. Any incompatibility between different 3D printed camera mounts. I also provide a design for a GoPro Hero 9 mount on the website AOS.RC. So if you want to do your own camera mount, you've got at least a template for one that you can look at so that you know exactly what size and shape to make everything so it's going to fit perfectly. When it comes to the hardware for the frame, there are going to be 2 versions. The version you're looking at here is the standard version. It has all button head screws on the top and all button head screws on the bottom. There will be a countersunk version as well, and the countersunk version will use countersunk screws for all the bottom screws, so they'll be countersunk completely flush to the carbon fiber plate here. And on the top, the countersunk version will have countersunk screws in these 6 positions here. And that will just allow you to use perhaps a thinner battery pad than you might be able to use with button head screws, and will avoid the screws interfering in any way with the battery that you want to mount on that top plate. So the last thing I want to show you is one of my test builds of the AOS 5.5. This is the 30mm stack in the center position and a full-sized DJI Air Unit in the back. And you can see there's still plenty of space up front. I've got a 1000 microfarad 35 volt capacitor and a FETTech spike absorber TVS diode in the front section. And there's still space for a V-Fly buzzer if I wanted to add one. The only consideration that I did have to make for this DJI Air Unit is I had to make sure the XT60 comes off the front of the ESC rather than off the back. So that's the only change that I had to make, is just turning that ESC round from the position that it would naturally be in. Obviously, you won't need to make that change if you're running an analog setup or a Caddx Vista, because they're much smaller pieces of hardware. I'm going to be doing another video where I look in depth at an AOS 5.5 build when I do my perfect AOS 5.5 build. So make sure you're subscribed if you don't want to miss that. I hope you enjoyed this video, and I hope that now you have a better idea about whether you would like a 5-inch frame because you run a lighter action camera like a Hero 5 Session or a Runcam 5, or whether you need a 5.5-inch frame because you are running a GoPro Hero 8 or Hero 9. If you'd like to learn more about the AOS 5.5 or the AOS 5, I'll put a link in the video description to my website, AOS.RC, where you can find a lot more information about both those frames. And if you'd like to order the frame, you can do. You can order it direct from CNCMadness, and international shipping is available. So I'll put a link in the video description to where you can go to order the frame as well. Until next time, I wish you all very, very happy flying.